Alright, welcome back. Calculating elasticity. In this video you will learn not one, but two different ways to calculate elasticity. Alright, so let's start by defining elasticity. We're going to use this to measure the responsiveness of one variable to some kind of change in another. In this first video, we're going to focus on price elasticity of demand. So we're going to be looking at how much does quantity demanded change based on the change of price of that good. More generally though, these two statements are true of elasticity in general. We're asking how responsive is the dependent variable to the independent variable. So if the independent variable changes, how much will that cause the dependent variable to change? Alright, so the type of elasticity we are focusing on in this video is price elasticity of demand. Alright, that can be defined for us as the ratio of the percent change in the quantity demanded to the percent change in the price as we move along the demand curve. So the price elasticity of demand is equal to the percent change in quantity demanded divided by or over the percent change in price. One of the major things to point out there is that these are percent changes, not just changes. So a percent change in quantity demanded divided by a percent change in the price. As we look, we'll see that's why it's not just the slope. It's not just the change in quantity demanded over the change in price. It's a percent change. So that's going to be one of the reasons that later on you're going to learn how price elasticity of demand actually changes along a single demand curve. But for now, this is our formula. We can think about it in context comparing two goods. We have gas and we have cars here pictured. If the price of gas changes, how much will that affect or change the quantity of gas demanded? On the other hand, if the price of this luxury car on the right-hand side, if that price changes, how much will that change our quantity demanded of luxury cars? Turns out that we will react very differently to price increases of gasoline compared to luxury cars. And so that's what we're getting in the next few videos. This video, however, is going to focus on just the math. Alright, so we have an example here. I'm going to walk you through how to solve an elasticity of demand question. Okay, when the price increases from $10 to $11, the quantity demanded decreases from 100 to 80 units. So this follows our law of demand. As we would expect, when the price increases, the quantity demanded falls. We know we have a downward sloping demand curve, so far so good. I think that should make sense. All right, now we consider our price elasticity of demand formula is the percent change in QD divided by the percent change in P, or price. So we need to figure out, well, what was the percent change in quantity demanded? We'll do that. We'll divide it by the percent change in price, and that will give us a number that will be referred to as our price elasticity of demand. The next video will show you what these numbers mean and how to interpret them. For right now, we're just focusing on the math. So for quantity demanded, this is just basic percent change. Okay, so we are going to do quantity demanded first. We take the second value, subtract the initial value, and divide it by the initial. All right, so final minus initial divided by initial. In this case, it's 80 minus 100 over 100, so that leaves us with negative 20 over 100, which equals negative 0.2. And then we multiply it times 100 because this is a percent change. So negative 0.2 times 100 equals negative 20%. We do the same thing for price. Final minus initial over initial. So we went from $10 to $11. So it is 11 minus 10 divided by 10. That equals 1/10. 0.1 times 100, because again we multiply by 100 for the percent, and we get 10%. That leaves us with price elasticity of demand equals negative 20% divided by positive 10%, which equals negative 2. However, this is an important thing to note, is that in economics, with price elasticity of demand, we know that the answer will always be negative because of the law of demand, because there is a negative or inverse relationship between quantity demanded and price. We know that there's that downward sloping demand curve. So as price goes up, quantity demanded falls. So the answer will always be negative. So we are going to use an absolute value here. So while mathematically you calculated the answer as negative 2, we will use the absolute value of -2, and our final answer will be that the price elasticity of demand equals 2. There is a second way to do this, and it is called the midpoint method. Now, our price elasticity of demand formula remains exactly the same, so it does not change. It is still percent change in QD divided by the percent change in price. This is talking about how we calculate the percent change. So normally a percent change in X equals the change in X divided by the initial value of X times 100. But in this case, we're going to use the average value of X, the midpoint. So what we're going to do is, again, we'll take the average value of X, we'll take the change in X like normal, so 100 minus 80, something like that. But then instead of doing, 100 was the initial value, so we do 100 minus 80 divided by 100, we now take the average of 80 and 100, which is 90, so we would do 100 minus 80 over 90. So instead of dividing 20 by 100, like we would have done normally, we will now do 20 divided by 90. And the main benefit is that this allows us, whether we're going forwards or backwards, we will get the same answer. Because think about it, when we're talking about from 80 to 100, normally, if we're going from 100 to 80, then our equation would be 80 minus 100 divided by 100. If we're going the other way, we're starting at 80 and going to 100, then it would be 100 minus 80 divided by 80. So while the numerator is the same in either case, the denominator would be different, and we'll end up with two different answers. The midpoint method solves that problem because it will be dividing by the average, so dividing by 90 for both of them instead of doing it this way. So this is a nice way to get one single elasticity value regardless of whether you're increasing or decreasing price or quantity or whatever the variable is. All right, so here it is. We're going to do a mathematical example now using the midpoint method. So I kind of didn't need to talk and say all that. Hey, look, it's the exact same numbers I just gave the example of. Wow, man, I'm good. All right, so our example is again going to be the same. Quantity demanded goes from 100 to 80. Price increases from $10 to $11. We're just going to figure out one of them because, again, once you figure out the percent changes, that's all that matters. Everything else you do the same as we learned before when you plug it into our price elasticity of demand formula. So in this case, we're going from 100 to 80. So we go to our final value minus the initial. So 80 minus 100. But now we're going to divide by the average of 180, which is going to be 90. So we end up with -20 over 90 times 100, which is -0.22 times 100, which equals -22.2%. What's nice about this is if you did it the normal way, when you go from 100 to 80, we would be at -20%. If you had gone from 80 to 100, you would be at -25, well, actually be a positive, but you'd be at 25%, and so that would be a problem here. So it's good that we have this midpoint method because it makes our lives easier in this way. If you haven't already, make sure that you subscribe to my channel. I appreciate it so much, all your support. Hit that like button for me. This has been a La Money production.